Hi! In this video I will show you how to build smart thermometer that can measure up to 800 centigrades for around €15. It will not require any soldering and complete setup shouldn't take more than 10 minutes. Finally, I will heat it up close to its upper limits to check how it really works. Let's get started! First we need a sensor. Checking various options, I came to the conclusion that for such temperature range I won't find anything cheaper than this set composed of K-type thermocouple and MAX6675 converter. You should be able to find one in your neighborhood by just typing MAX6675 in Google. Next we need microcontroller, preferably with Wi-Fi on board. There are many modules on the market that will do the job, but this time I will use Raspberry Pico WH. It's not the cheapest option, but this project is so simple that I don't want to play with creating custom PCB for it. And as this module comes with header pins, USB interface and voltage stabilizer already installed on board, I don't need to do anything beyond plugging the wires. Such simplicity is just worth additional €5 in my humble opinion. ESP dev boards also have all that, but Raspberry Pico is significantly smaller. And that's all about hardware. Now we just need some jumper wires to connect both things together. The actual wiring depends on how it's defined within a program for microcontroller. Of course you can write your own software if you like, but if you're not in a mood for coding, you can just grab my code from Stargate page. It's in do-it-yourself section just below the video. By the way, on the page you can also find all the information about Stargate system if you're interested. Link in description. Now I just need to connect all the wires as presented on diagram. And the minimum hardware setup is done. Of course it would be nice to have some case for it. I have a 3D printer, so I just made one especially for this project. If you have 3D printer too, models are in one package with code. Alternatively, you can just use small junction box or something similar. Time for software part. My code is using Stargate as user interface, so if you never heard about it, you may want to check these quick tutorials first. You will find how to set up local server and libraries in Arduino IDE. Links in description below this video. I have it done already, so I can just connect thermometer to my laptop, open the code in Arduino IDE, change Wi-Fi credentials to my own and hit upload. To check if it works, I open my local server in web browser and thermometer appears as expected. Status is ready means everything works just fine. From now on, I no longer need direct connection to a computer. I can power it up using any 5V power source, like power bank for example, and still have it available to any device within my local network. Time to see how it really works. Well, let's set this thing on fire. So far so good. Temperature is rising rapidly, as it should in such circumstances. It looks like packet slowly starts to glow. Now it's definitely glowing. Temperature seems to be close to stable, but flame is a bit misaligned. Need to adjust it. Good, that helped. Temperature is rising again. Nice, we just passed melting point for aluminum. And looks that's all my burner can do. It's way above what I need anyway, so I won't try to push it further. Considering how cheap this thermocouple is, it seems somehow surprising that it's still working after what I did to it. Give a like to thermocouple if you also appreciate its effort to stay alive on this test. And see my other videos if you're curious on how such thermometer can be utilized on DIY applications. Thanks for watching and see you next time.